This is Dr. Carroll, and this video is about polymorphism. Well, the word polymorphism is derived from Greek, and it means many forms. And so this is a pillar of object-oriented programming. And so, or we could say that object-oriented programming supports polymorphism. So let's talk about binding, because that's how polymorphism is implemented. But there's two types of binding. There's static binding and there's dynamic binding. Static binding is also called early binding. And so what happens is at compilation time, so the compiler determines the appropriate version of a method or a field. Okay, so now in Java, static binding only applies to final, private, and static method and fields. So if it's final, it's not going to, if it's private, or if it's static, then the compiler can already know exactly which method will be called with each method call or which field is going to be used. But now polymorphism requires something different. And so what it requires is dynamic programming. And so with dynamic binding. Dynamic binding happens at execution time is when we determine the appropriate method or field. This is also called late binding because compilation is obviously done before runtime, whereas runtime is later. So in Java, the public and protected methods and fields, what happens is the JVM is going to decide which one to use. And just to be clear, it's not the compiler. So that's the mechanics behind the scenes that we don't have to deal with, but that's what's going on. So let me talk about some essential ingredients to making a polymorphic call to help us understand how do we set it up, what do we need to do. And this makes a great quiz question. So first what we have to do is we have to have a method, we'll say method A, and it needs to be in a base class. Okay, so we have a method, and then we need to override that method, which means we're doing inheritance if we're going to be overriding a method, and I have another video about overriding methods. So the method A needs to appear in both the base class and a derived class, so a class that extends the base class. So we have to have two versions, and then so that we have an option, a choice of what to choose. And now here's the more complex part. So you have to have a polymorphic call, you have to have the call on the method. And so to call the method, we call it on an object of the derived type, but the object is the object reference is of the base type. Okay, so we've never mismatched what the object reference type is and what it's actually referencing. So this really begs for an example. So let me give you two examples. First, a mammal class and a dog class. So here is a simple mammal class. I've foregone the Java docs to just focus in on what's going on. Fairly straightforward class. We've used protected here because it's anticipated that it will be inherited. And so in the constructor, all we're doing is printing out, hey, the constructor was called basically for the default constructor, and then we have a parameterized constructor. This is just displaying that it is also called. And then we have this method speak that I want to point out. And so we're just saying, hey, the mammal class is speaking, because we're going to make a polymorphic call to speak. And so we want to be clear about which class it's being called from. Okay, so that's mammal. Now let's look at dog. Dog here is a derived class. It extends mammal. Okay, so we get age for free, And we're keeping track again of the constructor here, or what is being called, to help us remember that the base class constructor will be called first. And then we have a parameterized constructor here. We have our getters and setters. And then we are overriding the speak method. And here we're saying dog says woof woof, as you could pronounce it. Okay, so, and then I have a simple driver class that in main, I'm being very descriptive here, so when we look at the execution we can track what's going on. We're going to create a mammal object and call mammal speak. Okay, that's fairly straightforward. That's what we've done before. We're going to call a dog object and have it speak. Okay, so we've seen that sort of thing before. Now here's where it gets interesting. So notice we have a dog object and we're assigning it to a reference to a mammal object. Now a dog is a mammal, so this is okay. We can do this because a dog is a mammal, and so we can assign it. A mammal is not a dog necessarily. It could be a horse, a human. And so you can't do the other way around, but because a dog is a mammal, we can do this and we can reference it. Okay, so we create a new reference and we say, hey, reference our golden retriever here. Now notice we're going to call speak on it. And so now which is it going to call? Is it going to say mammal is speaking, or is it going to say woof woof? Which one is it going to do? And then furthermore to say, well, that was kind of contrived, you know, we're smart, we can see which one is going to be called when. The compiler obviously can figure out, well, yes, if we made the compiler smart enough. But then let's take it one step further and let's pass this mammal object to speaking. And speaking here takes a mammal object and we call speaking on it, and we'll just have it call its toString, and then we will call speak here. Now the reason to put it in the method call here in speaking is we have no idea, the compiler cannot know ahead of time. If we had a call to dog and a call to mammal, we could have made calls in speaking to that as well, and then it wouldn't know. It can't just set every call up here in speaking. It can't just always know that that is a dog speak or a mammal speak. It's going to have to figure it out polymorphically each time. The Java virtual machine is going to have to figure it out. And it will figure out this one and this one as well, but it's the object.speak that is really highlighting, at least for me, the showing that, hey, the compiler can't figure that out ahead of time, and so it needs to do that. So just for completeness, let's just add that here so that we make this a full example, and the compiler cannot guarantee what will be called in speaking. And so it's just a simple main there. So let's compile this. So we compile the method with main, the class with main in it. Woohoo! It compiles. Then we run it. And now look what it said. Okay. Creating a mammal object and calling animal speak. Notice it calls the mammal constructor, as we would guess, because from this new mammal call here. And then we called animal speak, mammal is speaking, and then we have our call to speaking here, and this is the default toString that we get from an object, the object class, and it says mammal is speaking, which is what we'd guess. Now let's create our golden retriever. So we create our dog object, and we're going to call golden retriever speak. So notice when we call new dog here, before it calls the dog, before it displays the dog, the dog the print line in the constructor for dog, then it calls the mammal object, and it doesn't know what to pass it, so it's going to call the default one with no parameters. Then we're here, we set these things, and then we're back to main, and it calls golden retriever.speak, and it says woof woof. And then we call speaking. Notice this is, again, we did not override toStrings, so we get the class and then some hash code for where it's stored in memory, and then it also says woof woof. Now this is where it gets interesting. Remember, what did we do here? Here we created a new mammal object reference, but assigned it to a dog. Then we called speak on it, and look what it did. It knew it was a dog, and so it called the dog's speak, woof woof. And just to illustrate it a different way, we call here in speaking, it's a mammal object, but it says, oh, I know it's a dog because this object is really a dog, because remember, a dog is a mammal. And so it knows it's a dog. It calls dog, it calls the toString method, but it knows its name, and then sure enough it says woof woof there. Okay, let me show another example to help paint all of this, just to see it a different way. So let's look at a payroll example. This is a classic polymorphism example where we have an employee class, a manager class, and a payroll class. So you could probably anticipate what we're going to have here. And so here we have an employee with a name and a salary. Yes, employees are much more than a name and a salary, but for these purposes, that's what we're doing. And notice we have a calculate pay here, and by default it's just going to return the salary. Now we look at a manager class, and it extends an employee because a manager is an employee, and so then managers have names and they have salaries, but for the purposes of this example, managers also have bonuses, and so we can set the bonus, and in calculate pay we are overriding it. We're saying, hey, override calculate pay, and instead of salary, do salary and bonus. Also notice here in the constructor, what are we doing? We want to set name and salary, and so we didn't do this in dog, but we want to set those, and so that's a different way of setting it, and so that we are calling the constructor in employee to be able to do that. Now let's look at payroll. So in payroll, it has a simple main here. We are creating both an employee and a manager, and we're saying employee's name is Jane and she makes $48,900, and Jill is a manager and she makes an even $50,000 with a whopping $100,000 bonus. And so then when we call pay employee, we can pass it Jane as the object reference to an employee or an object reference to a manager. And here pay employee takes an employee member, we'll call it staff to be generic, and so it says, hey, calculate the pay on the staff, and so it's either going to call the employee calculate pay or the manager calculate pay, and we're going to say, hey, who's getting paid? Get the name, which is from the base class, so we can call that, and then we've already called calculate pay. Now what we cannot do is we cannot call a get bonus or set bonus in pay employee, because employee, the employee reference, may not have that. If it's just the base class, it doesn't have that method, but a manager has it and is an employee. So if we're referencing an object from and the type is the base class, it needs to only be base class fields and methods of which we're accessing. Okay, so let's see this one. Java C, we need to do payroll. Woohoo, it compiles. Okay, run payroll. Sure enough, Jane gets paid. And did Jill get her bonus? Oh yes, Jill got her whopping bonus. You might hit up Jill to see if she'll pay for lunch. Okay, I hope you enjoyed that, and I hope that explains polymorphism. I think it's fascinating, and what it does, again, it helps us cope with the complexity of a large project by being able to treat different objects as their base form, but be able to do intelligent things that are based on their derived class.